Hello, folks. Again, we're going to be getting into steering, but this time we're going to talk about electric steer. This is the newest of all that we have out now. It's been around for quite a while. It's uh, more and more incorporated into vehicles. One, it's very effective, and because we went into uh, electric vehicles and we went into hybrid vehicles, and what happens when the motor is off on a hybrid vehicle, we still have to be able to control the steering wheel. And instead of going for a manual type steering, we went into an electric type steering. So we're using electric motors is what we're doing. So let's go ahead and get started. I want to go ahead and start the PowerPoint first. And this is a new PowerPoint again, and I will be uploading this also along with the other new ones that I've just received. And you'll be the first to actually see this. So to start off with, we've talked about hydraulic. I've talked a little bit about a manual steering. So now let's get into the electric part of it. And the electric part is really not that complicated, but it is got a lot of safety features into it too. So it's rack mounted, just like your rack and pinion. It has a column, a column sensors inside of it too. So all these sensors are making sure when you ask it to steer, it kind of jives, because it's going to take your motion and move it into an electric motor to actually go back and forth. Before we had a more of a direct connect with our hydraulic, which is air assist, because we still moved that steering wheel. It went through a shaft and it still went to a rack or it went to a box, and we still had a little bit of the manual feature to it, but it was a power assist. Now we're going to actually transfer that a little bit differently here. So here's one that's actually mounted, electric steer mounted into a actual system here. This is on a Lexus RX 400. And here's that little beauty here. So here I have my electric motor, and then this is going to take this and going to take all these sensors and actually cause it to push this rack in and out. So the main purpose of electric steering is to take place of hydraulic components that were previously used and put it into an electric motor to allow that assist to it. So types of motors actually are used. There's the electric DC motor. Some of them operate at 42 volts, and while others operate at 12. They have the EPS controls. It's the electronic unit that calculates the amount of needed assist. So instead of being all systolic, just like before with the hydraulic, there's only so much pressure for going down the street, whereas we get into park position, we're going to actually have more force going. So same kind of thing. So there's different types of inputs that they use, and we all come back to a body control module or a PCM, power steering, control module. We're going to have battery voltage going in, and like it said before, some of it's not just going to be 12 volts; it might be up to actually 42 volts. And then we have some torque, sensors going on. How much pressure are you putting into it? And then the position of the wheel, which gets really important when you're doing alignments. You want to make sure you have everything synced up when you're doing your alignments. And there is actually procedures for a lot of these electric steer systems. Uh, there's a driver information center that actually tells you if there's a fault in sublight. And there's actually computer, like I said before, we have that body control module, we have that power steering control module, and the power steering control unit, all talking back and forth to make sure everything syncs up properly. So it takes a little bit of computer knowledge to do a lot of this. And here's, showing some of the connections to it. And here's that steering gear again. It looks a little bit different than actually the regular hydraulic type system. And this is showing that, actually the rings that showing location. So we want to make sure we are in that particular location. This helps with also the amount of torque you're asking for it to do. This is a different picture of how that is, and showing kind of like the torque sensor working. Um, some of the modules are mounted right up on the steering gear itself. Um, Here is the steering shaft torques, and talking a little more about the steering tap. It's actually the steering shaft torque sensor. Uh, so that power, steering control module uses that steering shaft torque sensor to actually to put in, how much needed, how much assist is needed, instead of just all, because you turned it, it's going to give it all. It gives you that gradual amount depending on what you need. So this is, again, showing some more on that. Yeah, again, to actually work on these folks, you're going to have some kind of computer knowledge and some kind of electronic control knowledge too. So these are a lot. They are very simple when you start breaking it down, but you need to get trained on how to do these. So this is just a diagram what it would look like. So here's my torque sensors, my position sensors, and notice they have two, not just one. They want to make sure you are saying for sure. So both sensors have to agree. If they don't agree, it's going to put in a fault saying, "Oh, something's not right." But it goes into the power and steering control module, and then it comes out here into this motor. So this motor is going to give it a, which way to spin and what rate to. All right. And what is the purpose of steering wheel position sensor? Determine whether the steering is on center or not. Yeah, and that's where the alignment, when you're doing alignments, is what we're really critical when we're looking at too. So power steering motor, like I said, it's a DC. It could be 12 volts. It could be 42 volts. The motor, can be rated at, quite a bit of amperage. The motor assists through an actual worm gear type setup, kind of like your steering boxes, and a reduction gear located in the steering column housing. The motor draws about 750 to 1,000 watts or 1 horsepower for all full assist. Purpose, of course, we want to know the wheel speed. Is a vehicle going down at a certain speed? It's stationary. That's going to tell us a different rate of what we're going to actually give and assist as we go down the street, or if we're going into the park, or we're in a slow rate. This is going to give us a different. So it is a bunch of fault detection going on inside of it to make it safe. You don't want to just jam it over like that, and all of a sudden you're in somebody's lane or you're in somebody. So there's different fault codes. We haven't got into computer stuff yet, but we will. And when we talk about computers, we talk a lot about fault codes. And this is showing different case studies. But you'll see, the connections, for, one of the things I always look at, whenever I have a fault, is I look for actually fuses are blown. And if it doesn't work, then I'm looking for why doesn't it work? Is it not getting power to it? And this is one of the things that we do. We look to see, is it a blown fuse, is it a bad relay? And then after that, we start going down to the different steps that the manufacturer asks you to do. Self-parking, again, when we have cars that actually park themselves now. So this is part of that feature, electric steering, and the sensors are actually involved. It's going to wheel speed, what steering angle. It's also using electric sensors, or ultrasonic sensors, I should say, to make sure there's no other car parked in that part. The system and this self-parking varies by manufacturer. They do in different levels. I've seen a commercial where a guy was actually outside a parking garage, and he was like this, and all of a sudden the car starts up, pulls on out. And it was unheard of years ago, but there's a lot of that kind of stuff on YouTube if you want to see it. Diagnostic and testing, of course, it's always testing itself for faults. If it has a fault in it, it's going to disable that self-parking. And then if it's not going to work, then you need to take it in to have it repaired, or you're going to actually repair it yourself. So this is some of the features of electric steering. So remember that it's electric steering, instead of having a hydraulic or a manual type steering, it's using an electric system motor that actually, it gives assist, kind of like a hydraulic, but it uses electric motors to do this. And they're going to use sensors to see what road speed is going on. It's also going to see what demand is going on, and if it's straight ahead or not, to actually calculate how much assist it's going to give you. And I'm going to go ahead and kind of stop this now. Like I said, I'll put the newest. Gosh, I got to change my background because I can hardly see myself right now. Let's go ahead and stop that. There you go. Uh, I'm going to go ahead and post the newer PowerPoint that I just received. Hopefully, it's beneficial to you too. I may put up a few more videos too on the different ones, different systems are out there too. So look forward to that, and we'll continue on as we go on until I see you next time. And please don't feel afraid to inbox me and ask questions. If it's a general question, please feel free to go into the student lounge and ask questions there of your fellow classmates. And that way, you guys are all smart. Let's put it that way. And you maybe, oh yeah, I read it in page whatever. Or if I don't see kind of any motion to the answer, I'll try to jump in. I'll give you a little bit of time, but I'll try to jump in and give you the answer. And then, if you still don't get your answer, please inbox me. And in the inbox, I go to quite frequently. So feel free to inbox me if you have a question, or if you have a concern about your grade, or something coming up in your life and you want to share it with me. And I'd be very honored if you would. Anyways, until next time, I will be talking to you. Take care, and I'll talk to you soon. Bye.